First, I'm going to graph y equals negative 4 cosine of 3x. And then I'll change it into cosecant or into a secant, and I'll move it. So what does a cosine curve look like? Well, a cosine curve looks like this, except this one's negative, so it's going to look like this. Upside down cosine curve looks like this. We're going to go from 0 to 2 pi thirds because we take 2 pi to find its period and divide it by your frequency, divided by 3. So when I make my curve, I'm going to go from 0 to 2 pi thirds. Okay, so let me start graphing that, right? I'm going to get some of this down. Now I'm going to move it. I'm going to change it into a secant, but let's put the first part down, okay? Alright, so let's see. Pi thirds, 2 pi thirds, pi, 4 pi thirds, 5 pi thirds, and 6 pi thirds, okay? And I'll even go back, negative pi thirds, okay? So, real lightly in pencil, I'm going to draw this curve, okay? So, it's going to look like, I want this curve right here on my graph. I'm going to go down to negative 4 and positive 4. And it's going to start down, it's going to end down. In the middle, it's going to be up at 4. Fourth of the way here is the x-intercept, so the one curve looks like this. Let me repeat that pattern. Start, finish, okay. Next curve, there's 2 of them. And finally, I need 3 of them. Here, here, okay, and here, okay. Now, let's make it into a secant. Well, secant's going to have asymptotes, and the asymptotes have to be where you divide by 0. Here is where you divide by 0. So you can have an asymptote here, 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 and an asymptote here. Okay. Now, the secant happens to be the loops, alright? So very lightly, I'm going to put in the loops. The loops are right off of my cosine curve. So I got a loop here, I got a loop here, I'll have a loop down here. So I'm going to put in all my loops. The loops are actually my secants. Where cosine gets small, secant gets big. Where secant gets big, cosine gets small. Okay, so there's my loops in blue. But I got one last thing to do, and I'll put down the answer. I need to take the entire graph and move it down 1. So let's take my whole graph down 1. So I take my loops, because that's my graph. It goes down to here. So here's one loop. Take it down 1. One loop. Take it down 1. Take it down 1. Down 1, and so forth and so on. So the purple loops are the actual secant curve, and that's what we want with 12. Okay? Where are the vertical asymptotes? They are at pi 6. They are at pi 6, 2, 6, 3 pi 6, 3, 6, 4, 6, 5 pi 6, 5, 6 pi 6, 7 pi 6, 8 pi, see, 8, 9 pi 6, 9, 10, 11 pi 6. Those are where my asymptotes wind up. 13, let's do 13. So, before we do 13, we need to know what a cotangent curve looks like. Standard cotangent curve looks like this. Okay, standard cotangent curve looks like this. We're going to have asymptotes here and here. What we're going to do with this is we're going to make it upside down, and we're going to shift it pi 8 forward, okay? Alright, so let's see if I can do that. Take my graph paper, slide this up, put my axes in, and I'm going to go pi halves, pi, 3 pi halves, 2 pi, negative pi half. So I like to go every 4 squares. Let's make that 1. Let's make that 2, 3, negative 1, negative 2, negative 3. Okay, so now I want to take this shape here, upside down. My asymptote for right now, I'm going to put everything in lightly because I'm going to move it, is here. Here's my asymptote, and here. So we're going to make this upside down, so it's really going to look like this. Okay, and like this. However, now it's upside down. We're going to move everything pi 8ths forward. So everything is pi 8ths forward. So pi 8ths is 1 square. So I'm going to move this asymptote here. I'm going to move this asymptote here. And this asymptote here. Just 1 square, which is pi 4ths. Then I'm going to move my loops here. And I'm going to get a graph that looks like this. Here's my actual answer in purple. And we're going to move that there. And there. Alright. What's the phase shift? Well, that's easy. We moved pi 8ths. Phase shift is just pi 8ths. What's the vertical asymptotes are at, if this is force, 1/4, 2/4, 3/4, 4/4, 5 pi force. This is pi, which is going to be 4/4, 5 pi force. Hold on. 1, 2 fourths. 1/4, 2/4, 3/4, 4/4. No, I'm off. That's an 1/8. Yeah, darn it. Change my... Okay, 5 pi force is here, and 1/8, 2, 3, 4, 5/8. 5 pi 8ths. And there we have it. Okay, on the back side, we did the tide problem. I'll do it again, but I'll do it quickly because I think we did it in class. I'll do the tide problem again with you real quick. Tide problem, let's go through it slowly. Okay, I'm going to go through it all the way to 24 hours. I'm going to go 1, 2, 3, 4, 5, 1, 2, 1 a.m., 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 1800 or 6 p.m., 1, 2, 3, 4, 5, 6, 24 or midnight. Okay? So, high tide, this is high tide. 5 meters, 1 o'clock, right there. 8:45 is -2. One thing that's going to help me is I'm going to change this number to a decimal, 8.75, because we have 3/4, and it's a decimal, 3/4. Now, what is the time or the distance from here to here? From high tide to low tide is going to be going from 1 to 8:45. So this is a 7:45 is the length, the time it takes to go from high tide to low tide. That's the same thing as 7.75. Then the next high tide, it's got to go another 7.75. So the next high tide would be 1 plus 15.5, which put me at 16.5. So if I go 12, 13, 14, 15, 16.5, 13, 14, 15, 16.5, there's my next high tide. So my next high tide will occur at 4:30 p.m. Okay? Now, what's the period of the tide in hours? Well, it's going to be 7.5 plus 7.5, high tide to low tide to high tide, or it's going to be a 15, hold on, 15 even, right? Nope, 15.5, which is 5 hours and 30 minutes. Okay, that's the length That's the period of high tide, okay? What's the height at noon? We'll answer that after we graph it. The equation. You ready to start on the equation? All right, it's going to go like this. I'm going to call it a cosine because I can start here. Okay, so let's call it a cosine. Let's go, first of all, y equals some cosine. My amplitude of this graph, the amplitude is the max minus the min divided by 2, which is 7 over 2. The frequency, which is b, is equal to 2 pi divided by the period of this, with the length of this curve, which is 15.5. So that's going to be my frequency, 2 pi divided by a 15.5, parentheses x. It did shift horizontally by 1. And to find k, I take my minimum, which is negative 2, plus my amplitude, which is 3.5, gives me a 1.5, so I put my 1.5 here. This is my equation for this, okay? All right, I've got the equation. Next high tide, we already answered that. Next high tide's at 4:30 p.m. Now, to graph the tide over 24 hours, we've got that, but we can also put it in the calculator. So what I want to do is put this in my calculator. So a couple of things on my calculator. First, let's get the window to work. Radian mode for sure, right? Radian, got to have radian mode because of the pi's. And let's go to window. Let's go 0 to 24, right? 24. Probably negative 3 to 6. Let's put it in my calculator. Clear. Now, I don't really want to go 2 pi over 15.5, too many parentheses. So what I'm going to do before I do that, what is 2 pi divided by 15.5? And this answer is about a 0.40536. So if I use this number instead, it's easier than putting that in. So let's put it in. Y equals, ready? We'll go A. Here it is. Here's my equation. We're going to go 3.5 cosine, parentheses. Okay, what's my number I want to use? My 0.40536, parentheses, x, subtract 1, parentheses, parentheses. Got to do a double parentheses there, plus 1.5, okay, and graph it. Hey, it should look exactly like what we have on our paper, except for I did a full 24 hours. There it is, pretty cool. So here's high tide, low tide. Now if you want to know what the next high tide is at noon is, you could either plug 12 into here, or I'm just going to use my trace button, trace 12, and I get an answer, about 0.62, and that's in terms of meters. Okay, next high tide is it going to be, what is the height? 0.62 meters, and I got it just by plugging trace button 12, and I put it in. I got about a 0.62. Okay, now if the sailboat, I'd make this meters. I got to fix that. This meters. Can't have feet and meters. So what I'm going to do is this. I go to y equals, and I'll put 3 in. There's my 3 meters, and draw a line. So where I see my line, this is above 3 meters. Your boat's okay at the pier. Your boat's okay at the pier. This is bad news. Your boat's going to tip over. They call it keeling. It's going to tip over in this region. So let's find out when we should take our boat out. So let's go calculate our intersect button. First intersection. Going to it, going to it, going to it. Alright, about there. Second intersection about there. Guess. So at about 3.8. So if I draw a real rough picture, here's my, so this is going to be about 3.8, which is going to be 3 and 60 times this is 48. So 3:48 a.m. Take your boat out. Calculate. Intersect again. Let's get over here. Pretty close. enter guess, about 13.7, which is 1, and then times 60 is 06 p.m. So take your boat out between 3:48 a.m. and 1:06 in the afternoon. Don't get in your boat. It's going to be tipping over. And then we got one more spot we're going to have to take our boat out. Start intersect. And there it is. Enter, guess. Get about a 19.3, which is going to be 7. 60 times 0.3 is 18 p.m. So, take your boat out between here and here. Take your boat out again at 7:18. So between 3:48 a.m. and 1:06 p.m., don't be in your boat. And from 7:18 until the next day, don't be in your boat, okay? Now, 15, almost done. So we're going to let's draw a picture first. So it's going to be compressed to 12 centimeters, then released, okay? It's going to return to its starting position after 0.75 seconds. So if I go 0.25, 0.5, 0.75, it's going to go like this. But it has a dampening, so it's going to go something like this, and then slowly get smaller and smaller and smaller, okay? So let's find an equation. So let's use, first of all, our y equals our a e to the negative ct cosine bt, all right? A is our amplitude, which is 12. Y equals 12. E to the negative 0.5 t cosine. Now b is 2 pi, always 2 pi, divided by the cycle. It takes 0.75 to make a full cycle. So what is, so I go 0.75. So what is 2 divided by 0.75? And it's about 2.6 repeating. So we're going to go, or it's going to be, yeah, 2.6, good enough. 2.6 t. Okay, there's my equation, all right? Where's the height after 1 second? Let me see if I can put this in my calculator. Y equals, clear, 12 e negative 0.5 x, close parentheses, cosine 2.6666, just use a few sixes, x, close parentheses, window, let's go from 0, maybe 2 seconds, height of certainly 12, so let's go 15 to a minimum height of maybe negative 15. Let's graph it. Okay, there it is. It's damp and it's getting smaller. So if I want 1 second, let's just go trace and plug in 1, and I get about a negative 6.47 centimeters. Okay, that is it. Good luck tomorrow.